So it would figure that the one time I have to record a video for you guys, I wake up in the morning and my voice sounds like this. So you're just going to have to bear with me. Hopefully you'll still be able to hear what I'm saying and I don't hurt my throat too much. Alright, so we're going to talk about inverse trig functions. You might recall from chapter 1, in order to have an inverse, a function has to be one-to-one, which means it has to pass the horizontal line test. Now, our sine function looks like this, right? So if we try to subject it to the horizontal line test, we can see that any horizontal line is going to hit this graph in multiple points. So you might think we can't take an inverse of sine. But if we restrict our domain to a number of x values, so that if we restrict our domain such that we can take a piece of the sine graph so that it does pass the horizontal line test, then we can take an inverse. Just like we could take an inverse of half a parabola, but not the full parabola. So there are many regions that could be used, but because it's the simplest, the inverse sine function has been defined by restricting the domain to be from minus pi over 2 to pi over 2. So that is where we invert our sine function. So the inverse sine of x, which you can write as sine -1, this is what the button on your calculator says. You can also write it as arc sine, and these mean the same thing. So if we want to evaluate arc sine of x, we're looking at the sine of what angle is x. So we're looking at sine of what gets us x. Just like when we took, say, log base 2 of x, we were saying 2 to what power gets you x. This inverse works in the same way. Right. Because we're restricting the domain of our sine function to minus pi over 2 to pi over 2, that means that the range of our arc sine function is from minus pi over 2 to pi over 2. And because the range of our sine function was from -1 to 1, that is the domain of our arc sine function. So keep that domain in mind. If I ask you what is inverse sine of 3, well, you can say that does not exist, because 3 is not between -1 and 1. If I ask you what is the inverse sine of 1/2, this means what angle has a sine of 1/2. And you should remember that's pi over 6. Remember how I asked you to memorize those. I asked you for the arc sine, remember? Same thing. Inverse sine, arc sine, same thing. I asked you for the arc sine of minus root 3 over 2. Well, the angle that has a sine of root 3 over 2 that we know is pi over 3. But if we want to get a minus root 3 over 2, that means we have to be, on our unit circle, we need to be in quadrants 4 or 2 to get a negative sine value. And our arc sine is defined from minus pi over 2 to pi over 2. So that means that all negative values are in the 4th quadrant. So that is a 4th quadrant angle, and we give it as a negative angle, so it's minus pi over 3. So you need to remember where trig functions have what SIGN sign as well. I ask you what's the arc sine of -1. Well, we know that is right here. You might remember it as 3 pi over 2, but our range on arc sine only goes from minus pi over 2 to pi over 2. So we have to go this way, and that's minus pi over 2. So that's how we deal with our inverse sine function. Our cosine and tangent functions also fail the horizontal line test, but again, we're going to restrict our domain so that they can pass. For cosine, we go from right here to right here because over that interval we pass the horizontal line test, and that covers all the values of the cosine function. So our inverse cosine has a domain that is the range of this. It's still just from -1 to 1, just like our inverse sine was. The range, we restrict our cosine to go from this max to this min, which is from 0 to pi. So the range of our cosine function is from 0 to pi. So when you take an inverse cosine, this will get you angles in quadrants 1 and 2, because that's where 0 to pi is. For a tangent, it's pretty straightforward. You know, we fail the horizontal line test, but each period passes the horizontal line test. So for our inverse tangent, remember arc and -1 mean the same thing. For arctan of x, its domain is the range of the tangent function, which is all reals, and its range is from -pi/2 to pi/2. It's the same as the sine function. So this will output angles in quadrants 1 and 4. So keep in mind, for sine or cosine or tangent, for our regular trig functions, we input an angle and we get back a ratio. And for our inverse trig functions, it's the opposite. We input a ratio and we get back an angle. So we can evaluate various trig functions. I want the arc cosine of 1/2. Well, you probably remember that the angle that has a cosine of 1/2 is pi/3. So that would be pi/3. If I ask you what is the inverse tangent of -1, well, the angle that has a tangent of 1 is pi/4. To get a negative tangent, we need to go into quadrant 4 minus pi/4. If I ask you for the inverse cosine of -1.3, well, the domain of our inverse cosine is just from -1 to 1. -1.3 is not in that domain, so that does not exist. And I could ask you I could ask you more questions like that, but so you need to remember those angles that you memorized in order to evaluate these. So summarize really quick here. Inverse sine, the results go from -pi/2 to pi/2. So we're in quadrant 1 and quadrant 4. Inverse tangent is the same. Inverse cosine is different. We go from 0 to pi, so that outputs angles in quadrant 1 and 2. And since inverse cosine outputs angles in quadrant 1 and 2, you need to remember how to make reference angles. So if we want to take the arc cosine of a negative, say √2/2, well, we know that the cosine of pi/4 is √2/2. So now we need to find the pi/4 reference angle that's in quadrant 2. So we want this to be pi/4. So then this angle would be pi, which is here, minus pi/4, which is 3 pi/4. So that's a little bit trickier, because if you take the arc tangent or the arc sine of a negative, you just attach a minus sign to whatever your angle is. But with arc cosine, if you take the arc cosine of a negative, you're going to need to take pi minus that reference angle. Now remember, when you take a composition of inverses, they cancel each other out. From back in the day when we first talked about inverse functions, remember, if you plug in the value of the inverse function into the original function, it's the same as if you do it the opposite way, you just get back whatever you plug in. Now, that's pretty much how our inverse trig functions work as well, but remember that we weren't using our whole trig function. We had to restrict the domain. So because of that, there are some instances where it doesn't quite work exactly like this. Now, if you take the sine of the arc sine of some value, that is always that value. Okay, and the same holds true for cosine and for tangent. Okay, so if you take the sine of an inverse sine, you just get back the value. If you take the cosine of an inverse cosine, you just get back the value. If you take the tangent of an inverse tangent, you get back the value, keeping in mind the domain of our inverse functions. So if I ask you, what is the sine of the inverse sine of 0.6, well, they just cancel each other out. That's 0.6, right? And that works for most values, but remember that the inverse cosine and inverse sine have a domain from -1 to 1. So if I ask you to take the cosine of the inverse cosine of 2, well, we can't take the inverse cosine of 2, so the functions don't cancel each other out. This does not exist. Right? So just be careful. They do cancel each other out, but make sure what's inside the inverse function is a value you can take the inverse trig function of.